welcome to another session for hardware. Now today we are going to learn about the virtual memory. Now what is a virtual memory? Just suppose that your RAM or you are utilizing the data at your fullest and the RAM has been completely uh, utilized. Even though you do have a queue of the data that is coming. Now obviously this RAM cannot access more data. So will this data be wasted? Or will it wait in a queue? No, it won't be waiting in a queue. What do we have? We do have a hard disk that we consider is at a as an you may say a virtual memory. So the data will be going over there into the hard disk, and once the RAM is going to get free after processing the amount of the data that it is right now processing, so the data will be going towards from the hard disk, it will be going towards the RAM. So this concept is actually a virtual memory, that if there is more data than the RAM or than the capacity of the RAM, so it will be waiting into the hard disk drive so that it should not be wasted. And once the RAM is finished after processing a particular amount of the data from the hard disk will be going into the RAM. So there are few of the benefits of a virtual memory as well. First of all, we can just have a look onto the virtual memory, that what is mentioned over here. It says if RAM is completely utilized for processing of the data and there is still more data in a queue, we utilize virtual memory, as we just discussed. Basic concept behind virtual memory is RAM plus swapping space on the hard disk drive. That means where you are going to place your data on the hard disk drive, and once the RAM is going to be free, the data is going to come to the RAM. Now as we discussed that there are few of the benefits as well. Now what are those benefits? Number one, it says program larger than the physical memory. Physical memory is referred to as RAM over here. Okay, can still be executed because the part is going to be stored over there in the hard disk drive, and once the RAM is going to be free, so the remaining part of that particular instruction can come now. No need to waste memory with data not being utilized, and similarly you do not need to buy excessive RAMs for a huge amount of the money. You can just create up a virtual memory. But with the virtual memory, they come with the two things, that a disk thrashing and a thresh point. Now what do you mean by the disk thrashing? Disk thrashing is something, few of the times there is a lot much amount of the data that is into the queue. So it is you may say it is continuously swapped between the hard drive and then the RAM, or you may say the queue to the hard drive, then to the RAM, again from the queue to the hard drive and to the RAM. So this is known as a disk thrashing, and at this place there is the thresh point, that the processor or the microprocessor or the CPU of the system gets too much busy while transmitting or while swapping the data between the hard drives and RAM or a queue. So brings or it comes too much busy in that particular swapping, that it can't focus on actual processing or actual execution of the data. So due to which there might be a thresh point, or you may say there might be a place where the system gets hang or system gets stuck, or you may say your system might crash over there. So that place is actually known as a thresh point. Now further on, we will be moving towards the memory data storage. Now what is the memory data storage? Memory data storage is something that in this we will be learning about the units that we will be utilizing to calculate a file, that might be of you may say uh, the text file, it might be the image file, it might be the sound file. So we will be learning about few of them. So as we know that the smallest unit of the memory, we discussed in our first topic as well in the data representation, that the smallest unit of the memory, let me write it down for you for your reminder. Smallest unit of the memory is known as a bit. Okay, now if I'm going to combine those 4 bits together, that will make up a nibble. Similarly, if I'm going to combine 8 bits together, so that will give me a 1 byte. The combination of 1000 or 1024. Now what's the difference between 1000 and 1024? Earlier, when the course was not updated, we do utilize 1000 because the examiner allows us to calculate the file size with the help of the 1000 bits with the equivalency of 1000 bytes with the equivalency of 1 kilobyte. But now according to the new course outline, it says we will be utilizing the SI units. So according to the SI units, it's 1024 bytes will be equivalent to 1 KB byte. It is equivalent to 1 KB byte. Now we do not call it as a kilo, we do call it as a KB byte. Similarly, we are not going to call it as the mega, we will be calling it as the MB bytes. Similarly, GB bytes, TB bytes. Okay, so that's the reason I've mentioned over here in my notes both of the things. So the combination of 1024 bytes will be equivalent to 1 KB byte. Similarly, 1024 KB bytes will be equivalent to 1 MB byte. 1024 MB bytes will be equivalent to 1 GB byte, and then 1024 GB byte will be equivalent to 1 TB byte. So these are the units that we'll be utilizing for the file conversion techniques. Now, if we come to the file conversion techniques, so we do have two different formats, one for the image, one for the sound. Now for the image, we say that we are going to multiply two things. That's the image resolution, obviously that will be in the pixels, multiply by the colors in bits, or the color depth in bits, how many colors are there in bits. So we will be saying that, or we will be multiplying them together. But when it comes to the, or you first of all, color depth, so color depth is something that how many bits are we utilizing to represent a single color. Like for example, monochrome color takes single bit, but when it comes to an RGB, so it takes 24 bits normally. That's a red, green, blue, 1 byte for each, so that normally takes a 24 bits. Coming towards the sound, so sample rate in the hertz, sample resolution in the bits, multiply the length of the sample. And if we do have the stereo file, that means the sound file, and from coming to from the stereo, so we do have two speakers over there, the left speaker and the right speaker, so we need to multiply the result by 2 over there. Now in the next session, we will be checking out with few of the you may say examples of this, that how are we going to calculate this. Thank you so much guys. Allah Hafiz.